Today, I will review my Capstone project and discuss my final findings and relevant future steps. The problem for my project was to determine if certain school-level features could predict a high school's proficiency performance on state assessments for reading and math. The reason I was interested in this problem is because proficiency on standardized state assessments are used to assess and evaluate the performance of a school. By looking into this project, I hope that it can serve as a stepping stone to identify at-risk schools at an early stage so that targeted interventions, funding, or resources can be directed to such schools to help improve their educational outcomes in the future. For my project, I utilized publicly available data sets from various federal educational data repositories at the school level for a single school year, which is 2017-18. The reading dataset contains features specific to school enrollment, course offerings, staffing, neighborhood poverty estimates, and state assessment proficiency data. In addition, the math dataset contained these similar features as well as 4 additional features that were specific to math course offerings and enrollment. For the target variables, I utilized the school's percent proficiency in math and reading. The overall methodology for this project involved combining datasets from multiple sources, cleaning and applying necessary feature engineering steps such as one-hot encoding of the categorical features, standard scaling of the numerical features, and discretization of the target variable into 4 groups based on equal frequency distribution. This led to the creation of 2 master datasets, one for reading and one for math, that were used for modeling separately. I utilized various classification models such as logistic regression, SVC, KNN, decision trees, random forest, gradient boosting, and X-trees to train and test the 2 datasets. Based on the accuracy, precision, recall, and cross-validation scores of the different models, the best predicting model was identified. Lastly, feature importance based on the selected model was conducted to identify which of the features in the dataset provided the best information in relation to the target variable. Based on the different key metrics that were looked at for all the classification models, the gradient boosting model performed the best in comparison to others for predicting math and reading proficiency labels. As shown on the charts in the right, the accuracy scores for the different models reflect that the gradient boosting had the highest accuracy for identifying the proficiency labels for math and reading. Here is an example of the gradient boosting model while predicting the reading proficiency labels. As you can see, the gradient boosting model was able to predict the reading proficiency labels accurately roughly 50% of the time, given the selected high school level features. In terms of feature importance, the school neighborhood income poverty ratio had the highest relative feature importance score for predicting both math and reading proficiency labels. There were a few limitations that were encountered over the course of this project. Firstly, the binning of the target variable may have contributed to some loss of information or power. And secondly, the selection of features from the various data sources were limited due to missing data or suppressions being applied for various privacy reasons. As far as future work for this project concerns, we could look at utilizing other binning strategies such as entropy binning for assigning labels to the target variables. Various other features could also be incorporated, such as economic, education level, housing, demographics, and crime data from the census database on neighborhoods surrounding the schools. And lastly, we could utilize data from multiple years and additional grades to determine if there are any underlying factors affecting the target variable. And this concludes my presentation on the last phase of this Capstone project. Thank you.